Hey guys, welcome to lesson 12. Today's objective is going to be multiplying a decimal fraction by a single-digit whole number using estimation to confirm the placement of the decimal. And really, if you follow along, this is going to be a pretty easy, quick lesson for us. If you turn in your books to the problem set, we will get started. And just in case you're not sure, the problem set starts on page 57. Okay, number one, it says choose the reasonable product for each expression. Explain your reasoning in the spaces below using words, pictures, or numbers. I'm going to show you the real easy way to do this one, and hopefully you pick up on it pretty quickly. The whole number in letter A is a 2, and we're going to multiply that by 4. If I multiply 2 times 4, that's going to give me 8. And if we look, the closest of our 4 choices to 8 is going to be 10. So we could say, I know the product of 2 times 4 is 8. Therefore, the best estimate is 10. And real quick, we're going to have a delay in our game because the board is off, as you could see. So we're going to chase the arrow, chase the arrow, chase the arrow. I'm going to call that arrow right there Ned. Remember that I called that arrow Ned. It's going to be important. And we can get back to work. Okay, letter B. Oh, look at that. I cut out the numbers. Which one is it? So, again, same thing, guys. Look at the whole number. It's a 3, and we're multiplying that 3 times 7. If I multiply 3 times 7, that's going to give me something close to 21, because 7 times 3 is 21. So we're going to go with 21 and 98 hundredths. And then we're going to write, I know the product of 3 times 7 is 21. So the answer has to be 21 and a little more. Pretty easy so far, right? Number 4, we have a whole number of 8 and 6. And we do have a little bit more because we have 22 thousandths on it. If I look at the 8 times 6, that's going to give me 48. So I need an answer that has 48 and a little bit more. There it is. And we can say 8 times 6 is 48 and a little more. Letter D. Same thing, guys. 9 and a 5. That's going to give me 45 and then a little bit more. Out of those choices, 45 and a little bit more, we've got 49. So we can say the product of 9 and 5 is 45, and we need a little more. Okay, we're going to start work now on our word problems. Number 2 says Pedro is building a spice rack with 4 shelves that are each 55 hundredths meters long. At the hardware store, Pedro finds that he can only buy the shelving in whole meter lengths. So he can only buy 1 meter or 2 meters or 3 meters. Exactly how many meters of shelving does Pedro need? Since he can only buy whole number lengths, how many meters of shelving should he buy? And we need to justify our thinking. Okay, so we know that if we have one shelf, and we're going to do a tape diagram, that is 55 meters. But we are not only doing one shelf, we are doing 4 shelves. So we've got 1, 2, 3, 4. Each one of those is 55 hundredths long. So in order for us to get an answer, we're going to multiply 4 times 55 hundredths. And down here, I'm going to show my work in green. I'm going to have decimal point 55. We're going to multiply that by 4. 5 times 4 is 20. 5 times 4 is 20, plus the 2 gives me a 22. And then with decimal points, if we multiply over 1 over 2, over 1 over 2, that's going to equal 2 and a little bit more. Since we've got to do whole numbers, he's going to need to buy 3 meters of board. Pedro needs exactly 2.2 meters. Remember, we can leave that last 0 off of shelving. Therefore, he should buy 3 meters. He doesn't want to buy only 2 meters. He wouldn't have enough. So he's got to buy 3. On to the next one. Marcel rides his bicycle to school and back on Tuesdays and Thursdays. He lives 3.62 kilometers away from school. Marcel's gym teacher wants to know about how many kilometers he bikes in a week. Marcel's math teacher wants to know exactly how many kilometers he bikes in a week. What should Marcel tell each teacher? Okay, so we need an estimate and we need an exact. So let's do the gym teacher first. Okay, so Marcel's biking to school and back every day. So that's 4 trips. There and back on Tuesday, there and back on Thursday. So if we do a tape diagram, he's got his 4 trips. Each one is 3 62 hundredths miles. So we're going to have to multiply that by 4. 3.62 times 4. 4 times 2 is 8. 6 times 4 is 24. 4 times 3 is 12. Gives me 14. We've got 2 decimals over, so 2 decimals over. So he is exactly 14 and 48 hundredths kilometers. And then for the math teacher, he wanted to do an estimate. Math teacher, well, we know he does 3 62 hundredths, and we're talking about 4 trips. It might be off just a little bit, but if we think about it, we've got a 4 here and a 3 here. 4 times 3 is 12. Or you could round up to 4. You might want to do that. So if you rounded 3.62, if you rounded that up to a 4 times 4, that's going to give you 16. So either estimate I would have accepted, 12 or 16. And the last one that we have says the Poetry Club had its first bake sale and they made $79.35. The club members are planning to have 4 more bake sales. Leslie says if we make the same amount at each bake sale, we'll earn $3,967.50. Peggy said, no way, Leslie. We'll earn $396.75 after 5 bake sales. Use estimation to help Peggy explain why Leslie's reasoning is inaccurate. Okay, so we have $79.35, and we want to multiply that by 5 bake sales. If we do that, first thing I would do is round our $79.35 to $80. That's pretty close. So if we make $80 a bake sale and we multiply that by 5, 8 times 5 is 40. And we need to add on a 0. So that gives us $400. So we know that that is going to be closer. So Leslie did not estimate correctly. And just so you know, I gave you a name earlier. I said to remember that name. That is my grandfather's nickname. That will be important tomorrow in class. Hope you guys have a great night. Enjoy it. See you tomorrow.